Right, so this is the sketch that I've ended up with for the board, and this has got quite a lot of the by display code ported over. Now they've got all the display code in libraries, and I haven't done that because I want better control over the code. I want to actually do low power stuff, and I want to change this, so I don't want to go through the hassle of changing the library. I'm going to actually have this just as one file. Now at the moment there's just initialization in here, so there's no code for drawing lines and setting pixels and so on. I'll port that over later. So what we've got the pin, the two lines at the top with the pins, that's left over from the previous sketch. Then there's a load of constants here. Then you've got a function. Oh, hang on, what we got? Let's go right back to the top again. Right. So there's a few values for registers and things there. There's a couple of, well, 3 data types. Then you've got the pin definitions. So here the pin definitions are all for the STM32. These are different to the demo code, which was for the Arduino Uno. It turns out there's a few problems on the board, so I've already got this working, and it turns out that I've mucked up the hardware SPI. So I've got chip select and clock, I think it is, swap round, and I'm also using the SPI2, and it looks like that's a bit tricky to actually access in the STM version of the Arduino Arduino IDE. So what I've done is I've actually, down here, I've changed their code, and I've got an SPI write byte function here which actually just writes using digital write. So we're not using hardware SPI, it's a software form of SPI. Seems fast enough. So that's a new bit of code. Further up there's 2 functions here, SPI RAM read byte here and SPI RAM write byte here. Now on the original demo board I've got, which uses an Uno, there isn't enough RAM in the Uno to hold a display buffer. So what they've done is they've put an SPI RAM on the board, and they use that to store the display buffer. So when data's written, it actually goes over SPI, and when they update the display from the buffer, they read the SPI RAM. So I've not done that. In the STM32 F103C8 that I'm using, which came straight off a blue pill, I've got 20k of RAM, which is enough for a display buffer, and quite a lot more flash as well actually. So all I'm doing here, I've declared a buffer, and I'm just reading and writing from the buffer. So that's all internal to the one chip. The buffer's there, so that's just 2 times buffer size. So this has been set up for the black and red display. Turns out that's not a good idea, but I'll show you why later on. The rest of the code, I've just stripped out some of the library stuff so that I can just call the functions directly. There's no namespaces. So there's a reset function, there's a function to send a command, function to send data, wait until idle, set up the display window. It may be possible to update just part of the display, so that might be an optimization for the watch to save power. Epaper displays usually require the entire display to be set up, which is slower and will take more energy out of the battery. You can set the cursor, turn the display on. Init is interesting, so that is setting up the pin modes and the serial port and so on. So that's a bit like setup, it's called from setup. EPD in it is setting up the actual Epaper display, and this seems to be the same sequence. It's in the sequence from the datasheet, I think, for the controller, and it seems to be the same sequence for both the monochrome black and white and the black, white, red display, so that's just the same code. There's a clear, which actually does clear the display directly. It doesn't use the buffer and doesn't clear the buffer. Now you can see the zeros being written here. It's just going across every pixel or every byte of the display. sending 0 for the black and white, and sending 0 for the red. Display update, so that copies the RAM to the Epaper display, and at the moment I've just got a value which I write here. That isn't coming from the buffer because I haven't got any functions to write to the buffer, so that's just a value which I increment on every cycle. So the display just updates, putting binary values in every byte, so the whole display sort of has stripes on it. There's a sleep, so that puts the display in deep sleep mode, so we'll be using that. That'll be useful. Cut down on the amount of power used, so I'm hoping to put the display into deep sleep mode and then the processor into a sleep mode, go to sleep for quite a long period of time. I'm not sure how long, 5 minutes, at least a minute. So the display will only update once a minute at most, I think. Maybe 10 minutes, maybe 15. I mean, you could go into a very long mode where you just update very occasionally, but anyway, that's later. Depends how much power is used for an update, really, and the battery life that is needed. This is the Arduino setup function, so that's just setting up the serial port again. It's done twice, isn't it? I just noticed that's in the init function as well, and the pin modes, so it needs a bit of a tidy up. There's some display stuff there which I don't want, so I init the display here, initialize it, clear it, and then sit in a loop, and every 5 seconds it just updates the display and then changes the value that the display will be updated to, so the stripes change every 5 seconds. And in the loop, so that is turned off now because this while loop here will override that and you'll never get into the loop, so there's nothing coming out of the serial port at the moment.